Hey, welcome to Dissolve Chemistry. In today's class, let us dissolve a concept of internal energy. In the previous video, we have discussed regarding heat, energy, as well as work. So, as already we have discussed regarding energy, you might be worrying that what do you mean by this internal energy? Say, for example, we will consider a system containing, for example, you take 1 mole of gas. So as it contains 1 mole of gas, so we know that how many number of atoms or molecules will be there? 6.023 into 10 to the power 23 number of constituent atoms or molecules will be there, or molecules. Fine. So these many number of atoms and molecules will be there when you take a system of 1 mole of gas. Now what do you mean by this internal energy? Say when you take a 1 mole of gas means number of molecules will be there. There will be a different types of energies are associated with these molecules. Small different energies. Say for example, molecule will be having kinetic energy. Kinetic energy is due to what? So due to motion of the molecules. What type of motions? Rotational motion, translational motion, vibrational motion, and electronic transition may happen. So all these are associated with the small energies. They have, apart from that, they too have a intermolecular interactions. One molecule will repel with other or attract with each other, or there will be an intramolecular interactions will be there, and there will be some bond energies, and all these different types of energies associated with the system we call put together as internal energy of the system. Okay, it is the sum of all different kinds of energies, different kinds of energies associated with the system is called internal energy. So therefore internal energy, it is represented by U. So therefore U is equal to, you can say, kinetic energy plus potential energy of the system. Okay, and here we have considered system as 1 mole of the gas. Kinetic energy may include like translational, rotational motion of the molecule, then vibrational motions of the molecule, transition, electronic transition may happen. Okay. So all these put together we call it as kinetic energy of the molecule, and potential energy means you can include intramolecular interactions, and then you can say intermolecular interactions, and you may have some bond energies, etc. So all these put together we call it as what? Internal energy of the system. Now let us look into this. Say for example, this system is at now 25 degrees Celsius and your pressure is, say for example, 1 atmosphere. Okay, temperature is 25 degrees Celsius or 298 Kelvin, you can say. Okay. So now, for example, you consider, now what I am doing, I am heating the gas. Okay, or energy is absorbed by the gas. Then what happens? Obviously the temperature will rise. So now I varied temperature from 25 degrees Celsius to, say for example, 50 degrees Celsius. Do you think that internal energy of the system remains same? It is going to change, because as they absorb the energy, the temperature is going to change, and because of that what happens? Even internal energy are also going to change. How it will change? You look into this. Translational, rotational, vibrational and transitional energies, all that are going to be changed, or it is going to increase. Okay, and intermolecular interactions also increase because we are confining that one in a cylinder and we are not allowing it to do work. So therefore what happens? Internal energy of the system is going to what? Increase when the temperature is raised. Is it going to depend upon either the how we brought that change? No, it is not going to depend upon that. It is going to depend upon the only initial and the final state of the system. In what way you have given energy, you have added energy to the system, it never matters. Okay, it only depends upon the initial and the final state of the system. So therefore, and another thing important is that we cannot determine an absolute internal energy of the system. Instead of that, we are going to determine change in internal energy, which is equal to U2 minus U1 or U final minus U initial. Similarly, it is a state function as already I have mentioned. So the way you have brought change in the system, internal energy will not depend. It only depends upon the state what now and what it was earlier. Okay, so therefore it is a state function. Now if I confine this in a cylinder, if you make this 1 mole of gas is confined in a cylinder which is fitted with a piston. Now what we will do, say for example, it will absorb the heat energy at constant pressure, for example, you can consider. So when it absorbs the energy, then what happens? Immediately its internal energy will rise. Okay, and as internal energy increases, then what happens? Certain amount of energy may be utilized to lift this piston up. So therefore we call it as change in internal energy is equal to Q plus W. The Q amount of the heat is absorbed by the system and it is doing certain work that we call it as W. Okay, expansion work it is doing. So therefore mathematically we are going to give this delta U as Q plus W. And the sign what is being mentioned in front of Q and W, so that depends upon either the work is done on the system or done by the system, or heat absorbed by the system or heat given out of the system. Okay, next we will see the various conditions under which the signs of these two are how they are going to vary. Okay, so let us see the different conditions. Fine. Well, first we will take condition number 1, that we will take 1 mole of gas is fitted in a cylinder or confined in a cylinder. Now what we are doing is, suppose I am giving heat energy to the system, means heat is added to the system. Anything is absorbed by the system, we indicate by positive sign, which is added to the system. So therefore Q amount of heat is absorbed, and in the meantime it is doing work, expansion work it is doing. What type of work? Expansion work. Then there will be a change in volume also we see. So then your delta U will be given as Q amount of the heat is added to the system and it is doing expansion work, means W amount of work is being given out. Okay, so means certain amount of energy is utilized to increase the internal energy by absorbing heat, and meantime it is utilizing certain amount of energy to expand. So therefore delta U is equal to plus Q minus W. Then we will see the second condition, when it will be, what will be the sign of your, okay, so 1 mole of gas, once again same thing, we will take 1 mole of gas. Now heat is absorbed by the system, Q amount of heat is absorbed, and another side what we are doing, we are compressing the gas, means compression work we are doing. So therefore what? From both sides it is added to the system, means work is also done in such a way that leading to the increase in internal energy. In the meantime, the amount of heat absorbed also lead to the increase in the internal energy of the system. So therefore delta U is equal to plus Q plus W. Okay, means both are adding to the internal energy of the system, and internal energy of the system is obviously going to increase. And in the first case, that depends upon how much amount of the heat is absorbed and how much amount of the work is done. So increase in the internal energy depends upon the magnitude of the energy utilized to do the work. So then third case is, so when you allow this gas, okay, so you are doing work on the system, means compressing the gas, and in the meantime what is happening, your heat is allowed to go out of the system. Okay, so it is a closed system, or diathermic walls are there. You should remember that heat can transfer in and out of the system. So therefore now what you will be seeing, that W amount of the work is done on the system, means work is adding to the internal energy, whereas Q is being given out. Certain amount of energy is given in the form of heat. So therefore delta U is equal to, what will be the sign? Work is added, so therefore it will be W plus W, and Q amount of heat is going out, so therefore it will be minus Q. Okay, then last condition we will see that our system is, one way it is expanding, okay, doing expansion work. This is compression work, here also compression. It is doing expansion work, and other side it is heat is given out by the system. Okay, from both way, internal energy is being utilized to give out as a heat as well as a work. So therefore what do you expect? So the delta U is equal to, okay, so it is going out means minus Q, work expansion it is done, minus W. So this is how we are going to see the signs of the Q and W when we means various ways how it is going to vary. So in general, how we write delta U is equal to plus or minus Q plus or minus W. Okay, so this is how we are going to represent change in internal energy. Plus and minus sign depends upon, plus means you should remember added to the system, maybe in the form of work or maybe in the form of heat. If it is added to the system, then we call it as what, or we indicate by plus sign, and if it is given out, then we indicate by minus sign. I hope you have understood what you mean by internal energy, and how its mathematical form is going to have different signs of heat and work. So I hope you have understood. So we'll conclude here, and next step watch and our videos. Okay, next topic will be types of process. Thank you.